Lesson 11.4, Multiplying and Dividing Rational Expressions. To multiply rational expressions is very much like multiplying fractions. Step 1, you cross-cancel if you can. Step 2, you multiply the numerators. Step 3, you multiply the denominators. And then you simplify. Okay, so let's try number 1. 3x over 16x squared times 8x squared over 3. So what we need to do is cross-cancel any common factors if you can. So the 3's cancel each other. The 16 and the 8 we can cross-cancel by 8. The 16 becomes a 2. The 8 becomes a 1. X squared and x squared cancel each other. So we're left with x over 2. Number 2, x plus 3 over x times 5 over x squared plus 7x plus 12. The first thing I need to do is I'll need to factor this trinomial. To see if there's any factors that I can cross-cancel. So let's do that. This trinomial can be factored using P and S. So this would be x plus 4 times x plus 3. Okay, so here we see that we can cancel the x plus 3 with the x plus 3. And basically that's all that we can cancel. So let's go ahead and multiply across. 1 times 5 is 5. And then x times x plus 4 can either be written as x times x plus 4, or you can go ahead and distribute and write it as x squared plus 4x. So either one of these would be a correct solution. Okay, let's try number 3. Write this down. Y squared minus 3y minus 4 over y plus 5 times y plus 5 over y squared minus 4y. So what I'm going to do is I'm going to factor the two highlighted expressions so that then I can use the cross-canceling technique. Okay, so let me bring this down. This is y plus 5 here, and then we have y plus 5 there, and then I'll factor that. Okay, so up here, y squared minus 3y minus 4, I'll use P and S to factor that, and I have negative 4, positive 1. And here I can factor out a GCF of y, and I have y times y minus 4. Okay, so I'm just rewriting the expression with any expression that could be factored, okay? All right, so now let's cross-cancel. Y minus 4, y minus 4, y plus 5, y plus 5. And let's multiply across. We have y plus 1 over y. And so this would be my solution. Try number 4 on your own. Pause the video now, work on that, come back and check your answer. Okay, check your answer. You should have 1 over a times a minus 2, or it can also be expressed as 1 over a squared minus 2a. Okay, let's go on to dividing. In order to divide rational expressions, it works just like it does for dividing fractions. You first have to rewrite the division problem as a multiplication using the multiplicative inverse. For example, if I have A over B being divided by C over D, I need to take A over B and multiply it by the reciprocal, or D over C. So the same rule applies here when we're talking about rational expressions. Then you cross cancel if you can, multiply the numerators, multiply the denominators, and simplify. Okay, let's do number 5. 12a squared divided by 5b divided by 25a over 6b squared. So my first step is to rewrite this division problem as multiplication. So the first expression remains just the way it is. 12a squared over 5b. And then instead of dividing, I'm going to multiply by the reciprocal. So the second expression, or the one that you're dividing by, needs to be flipped. So we have 6b squared over 25a. Okay, now let's cross cancel. A squared becomes a to the first power, and the a is canceled. The b is canceled, and this becomes b to the first power. And in terms of my coefficients, there's really nothing that I can do to reduce or cross cancel. So I'll multiply across. 12 times 6 is 72, AB, over 125. And that would be the product. The quotient. Okay, number 6. Write it down, please. 4d minus 8 over 2d minus 6 divided by 2d minus 4 over d minus 4. So I will factor each of these one at a time. 4d minus 8 can be rewritten as 4 times d minus 2. And then 2d minus 6 can be written as 2 times d minus 3. Okay. And then 2d minus 4 is 2 times d minus 2. And d minus 4 is already simplified. So then my next step is to take the division problem and rewrite it as a multiplication problem. So here's what we have. 4d minus 2 over 2d minus 3 times d minus 4 over 2d minus 2. Okay. Now before I multiply, I'm going to reduce by cross-canceling. So d minus 2 and d minus 2 cancel each other. 4 cancels out the two factors that I have. All right, so I'm ready to multiply across. That's all of the common factors that I have. I have d minus 4 in my numerator, and that's over d minus 3 in the denominator. And this is my quotient. Okay. Number 7. Try this one on your own. Okay, check your answers. You should have b plus 1 over 3 times 3b plus 2, or if you distribute it, it should be b plus 1 over 9b plus 6. Either one of those is correct. Okay, let's do number 8 together. Okay, first let's factor everything that can be factored. I know that I can factor p squared minus 4 because I recognize that as a difference of squared. P squared minus 4 is p plus 2 times p minus 2. And that's all that can be factored. So let's rewrite this expression as a multiplication. So we have p plus 2 times p minus 2 over 5p times p plus q over p minus 2. Okay, so I can cancel out the p minus 2, and then I will multiply across. So I have p plus 2 times p plus q over 5p. And that's one way that you can express the answer. And the other way is you can go ahead and FOIL, multiply the numerators. So if you do that, you get p squared plus pq plus 2p plus 2q, all that over 5p. So either one of these will work. Okay. Okay, number 9, on your own. Pause the video and divide these two rational expressions. Okay, check your answers. Okay, number 10 we'll do together. Let me first factor this trinomial. B squared plus 6b plus 5 is b plus 5 times b plus 1. B plus 5 here is over 1, and then I can also factor out a 6 here, and I have 6 times b plus 1, like that. Okay, let's go ahead and rewrite this as multiplication. So I have b plus 5 times b plus 1 over 6 times b plus 1 times 1 over b plus 5. Okay, so I can cross cancel here, b plus 5 and b plus 5, b plus 1 and b plus 1. Any factors, as long as there's one in the numerator and one in the denominator, can be canceled. And let's multiply across. The answer is 1/6. Number 11, you're on your own. Pause the video now. Okay, please check your answer for number 11. Okay. Multiplying rational expressions is also used in dimensional analysis. Dimensional analysis is the process of carrying units through a computation. So, for example, number 12, convert 46 feet per second to miles per hour. So, in looking at this problem, we want to convert feet to miles and seconds to hours. There are 2 unit conversions that need to be accounted for here. So let me help you set up this problem. 46 feet in 1 second. And so we're going to have to write up 2 conversion factors and multiply. One that takes feet to miles, the other that takes seconds to hours. And at the end, we will have miles per hour. So again, we're going feet per second, from feet per second to miles per hour. Okay, so let's go ahead and set up those conversion factors. Let's work with feet and miles first. In order to convert feet to miles, we have to find out how many feet are in 1 mile. Well, 1 mile equals 5,280 feet. If you don't know that by heart, in the back of your algebra book, there is a conversion table that takes you through all the conversions of the customary system. Okay, so that's one conversion. And then we have to also talk about seconds to an hour. How many seconds are there in 1 hour? Well, there's 60 seconds per minute times 60 minutes in an hour. 60 times 60 is 3,600 seconds. Okay, so what I would like to do is show you how our units cancel each other, and we wind up with miles per hour as we multiply across. Okay, so take your calculator. Let's go ahead and calculate 46 times 3,600. Well, that is 165,600. And then in the denominator here we have 5,280. Let's go ahead and simplify that by dividing. Okay, when I round to the nearest tenth, I get 31.4 miles per hour. And that would be our answer. Okay. All right, let's look at number 13. I want to take 28 milliliters per second to cups per minute. Okay, this problem does give us a little hint, and I'm going to write that hint down for you. And the hint is going to help us convert milliliters to cups. It says 1 liter is approximately 0.908 quarts. Okay. All right, so this is going to take a little bit of work. Let's set this up. 28 milliliters in 1 second. And we want to wind up with how many cups in 1 minute. All right, let's work on the time, minute to seconds. That's easy. We know that there are 60 seconds in 1 minute. Okay, and now this one is going to be a little more complex. We're going to go from milliliters to cups. The hint that they give us tells us that 1 liter is 0.908 quarts. Okay, so let's first go from milliliter to liter. Milliliter to liter. So we know that 1 liter, and I'll write the L like that so that I don't have to write out the whole word. Okay, 1 liter is equal to 1,000 milliliters. We know that. And then we know that 0.908 quarts is equal to 1 liter. And now we have to go from quarts to cups. So how many cups are there in 1 quart? There's 4 cups in 1 quart. All right, so let's just start by canceling all of our units. So milliliter, milliliter, seconds, seconds, liter, liter, quart, quart. And if you look, we're left with minutes, cups per minute, which is what we want. All right, so take out a calculator. Let's multiply across the numerator. We have 28 times 60 times 0.908 times 4. And so here I have 6101.76. And then in the denominator, and I don't have 1 yet, but I will get there eventually. Okay, I have 1,000. Okay, and then we're going to divide to simplify. And so when I round to the nearest tenths, the answer is 6.1 cups per minute. And that would be the answer. Okay. All right, so a little independent practice here today. A few problems to work on. Here you're multiplying. Do number 5 and number 10. And here you're dividing 7, 10, and 13. Okay, we will continue to multiply and divide rational expressions as well as do a little dimensional analysis, converting units tomorrow. So God bless you. Remember to write down your informed questions and we will continue tomorrow. God bless you. Have a great night.